What is a regular polygon? A polygon is any shape with straight line sides. Here are a few examples. A regular polygon is a polygon that is equilateral and equiangular. This means its side lengths are the same and its angles have the same value as well. Let's take a look at a few examples for these. Notice that the example of a square appears under both categories. This is because a regular polygon is just a more specific version of a polygon. Today we will learn how to find the area of a regular polygon. Let's take a look at our steps. First, besides a triangle itself, any regular polygon can be divided into a number of equal triangles. Next, if we find the area of one of these triangles, we can then multiply it by the number of sides to find the total area. However, before we do any of these steps, we must first find the measure of an interior angle of the regular polygon. But what is an interior angle, and how do we find it? To figure this out, let's consider a regular or equilateral triangle. Let's label the angles of the triangle angles A, B, and C. Angles A, B, and C would be the interior angles of this triangle. To continue, let's recall two facts for this situation. The first is that the angles in any triangle sum up to 180 degrees. The second is that in an equilateral triangle, the angles are the same. Therefore, angles A, B, and C are equal. That means if we take 180 and divide it by 3, we get 60 degrees, or the value of one angle. This shows that the value of an interior angle of a regular triangle is 60 degrees. Now let us practice finding the measure of an interior angle of a square. Let's label these four angles A, B, C, and D. These will be our square's interior angles. Next, let's cut the square in half and replace angles A, B, C, D with angles 1 through 6, where angle A equals angle 1, angle B equals the sum of angles 2 and 3, angle C equals angle 4, and angle D equals the sum of angles 5 and 6. As we can see, the sum of angles A through D is equal to the sum of angles 1 through 6. Also, we can see in our figure that angles 1, 2, and 6 are part of one triangle, and angles 3, 4, and 5 are part of another. Each set therefore totals 180 degrees. If we add together the equations, we can see that the sum of angles 1 through 6 is 360 degrees. Therefore, the sum of the interior angles is 360 degrees, and since there are four angles, we divide 360 by 4 to find the measure of a single interior angle. Now let's take a look at a seven-sided regular polygon, otherwise known as a heptagon or a septagon. We will first try to find the measure of an interior angle of the heptagon. Then we will use that to find the overall area of the shape. First, let's label the interior angles from A to G. As these angles are all equal, our goal is to find the measure of one of them. Let's divide up the heptagon in a zigzag fashion and replace angles A to G with angles 1 through 15, as shown in the figure. The equation shown allows to compare the alphabetic versions of the angles with the numeric ones. Let's take a moment on our own to have a look at these. Note that both the alphabetic and the numeric angles sum up the interior angles of the heptagon. Now let's take a look at the triangles created by our zigzag lines. Similar to the square, we have various sets of three angles totaling 180 degrees. We can sum up all the angles on the left side and add up all the values on the right side. This gives us 180 5 times, or 180 times 5, which gives us 900 degrees total. And this means that the sum of the interior angles of a heptagon is equal to 900 degrees. To calculate the value of one interior angle, we take the sum of all the interior angles, 900 degrees, and divide it by the number of sides, which is 7. This gives us approximately 128.57 degrees as the value of one interior angle of a heptagon. Now that we have found the interior angle of a heptagon, we can use it to find the area. First, let us fill in this value for the angle in our figure. Let us also give this heptagon a side length of 10. Now, as mentioned in the beginning of the video, our strategy is to divide this heptagon into 7 triangles, find the area of one triangle, multiply by 7 to find the total area. Let's zoom in on one triangle and figure out its area. Given that the interior angle of the heptagon is 128.57, the triangle we are looking for will have half of that value, or 64.285 degrees. We now have an isosceles triangle for which, if we draw its height, it will divide the bottom segment into 2 equal parts. This also creates a right triangle for which we can use trigonometry to find the length of the height. Letting x be our height, it is opposite the angle we are given. Additionally, we are given the length 5 adjacent to the angle. Because we are looking for the opposite and we are given the adjacent, we use a tangent function and set up the equation tangent of 64.285 equals opposite, which is our x, over our adjacent, which is our 5. We multiply 5 to both sides, which allows us to cancel 5 on the right side to create just x. Plugging in 5 times tangent 64.285 into our calculator, we get x, our height, will be approximately 10.382. Now we can find the area of the triangle with our equation 1/2 base times height. Plugging in, we have 1/2 times 10 times 10.382, which gives us 51.91. Finally, to find the area of the heptagon, we take our 51.91 and we multiply by 7 to get our final area of 363.37 units squared. If you have any further questions, please message me on Schoology and I will be happy to help you.